Excel, GCSE, Mathematics Linear, Paper 3, Non-Calculator, Higher Tier, 18th of May 2009. On the formula sheet you are given some common formula that you might want to use in the exam. If you have any others that you feel you struggle to remember during the exam, take the opportunity in the first 30 seconds to write them down on this page. On question number 1, we're given a two-way table and some information about 100 children and how they travel to school. And we're asked to complete the two-way table in part A. So first of all, I'm going to work out this number here, and I can tell that as 54 added to this number is 100, and this number must be 46. Similarly, in the other column I've got 14 and 16, so this number at the bottom would be the sum of those, which is 30. And in the first column for walk, I've got 15, and this number here added onto that gives me 37, so this would be 22. And by the same logic, I can use 15 and 14 here, added together would give me 29. So I need to add on something to them here to give me 54, and that will be 25. And finally, this number at the bottom here will be 33, 25 added to 8. In part B, I'm told that one of the children, of which there are 100, is picked at random, and I'm asked to write down the probability that they walk to school on that day. Well, the childs that walk to school are given here as 37, so the probability is 37 out of 100. On question 2, I'm told to simplify 4x plus 3y minus 2x plus 5y. So to start with, I've got 4x, and I want to take away from that 2x. So 4x take 2x would be 2x, and that's the first part of my answer. The second part of my answer is found by doing the add 3y, and then adding on another 5y, which would get me 8y added on. So it would be 2x add 8y. In part B, question 2, I'm told that compasses cost c pence each, and that rulers cost r pence each. And I'm asked to write down an expression that would give me the total cost for two compasses. So one compass is c, and the second compass would also cost c, so that's two compasses. Added together will be the cost of 2. And 4 rulers, so 1r plus another r plus another r plus another r. And the total cost will be those two added together. And here, therefore, I'm going to have 2c. Here I've got 4r, and I'm adding the two together. So the final answer is 2c plus 4r. On question 3, I'm told to complete the table of values, and for y equals 4x minus 3, and I'm given some of the values in the table. So the first thing I'm going to do is I'm going to plot them on the graph and given below. So I've got here x is negative 2 and y is negative 11. So I'm going to plot that point on my graph. So along the scale to negative 2 on the x-axis, and then down to negative 11, which is down here. Notice that I've got to make sure I use the scale and not just count squares. Similarly, I've got this point here, which will be 0 to negative 3, which will be 0, and then down to negative 3. And the final one, I've got 3 and 9. So across to 3 and up to 9. Now, looking at those 3 points, they're in a straight line already, so I should be able to join them from one to the other, going all the way across my graph. And I need to add a little bit on at this point down there. Now, from that, I can actually work out the points I'm told to find in part A. So if an x is negative 1, I could actually come down and read that off here, and that would be negative 7. And similarly, when x is 1, I can come up from here, and that would give me that y is 1. And similarly, when x is 2, I can go up from 2 and find out that y, therefore, will be 5. Now, I also need to be able to do that by substitution. So, in the first part of the question, I'm told that y equals 4x minus 3. So, when x is 2, 4x minus 3 would give me what y is. So, when x is 2, 4x minus 3 would be 4 lots of 2, take away 3. So 4 lots of 2 is 8, 8 take away 3 would be what I got in the first part here. And similarly for x is 1, when x is 1, 4x minus 3 would be 4 lots of 1, take away 3, which would be 4, take away 3, which is 1. And I got that answer here. If I'm struggling to work out the negative here, I can always just use the pattern in the table, which is that y is going down by 4 each time. And therefore, I can take 4 off negative 3 and get negative 7. And that's both parts A and B answered. On question 4, I'm told that P equals 4k minus 10 and that P is 50, and asked to work out the value of k. So if P equals 4k minus 10 and P is 50, then where there's a P, I'm going to replace that with a 50. So 50 equals 4k minus 10. And I'm now going to solve that equation. So the first thing I'm going to get rid of is I'm going to get rid of negative 10, so I'm going to take away 10. I'm going to add 10 to both sides. So on the left hand side I'm going to get 60, and on the right hand side I'm going to get 4k. Now this is 4 times k, so to get rid of the times I'm going to divide by 4. And then on the left hand side I'm also going to divide by 4. And that will get me that 15 is equal to k. In part B of the question I'm told that y is equal to 4n minus 3d. And that n equals 2 and d equals 5. And I'm told to work out the value of y. So by the same logic, y equals 4 lots of n, which was 2. And I'm going to take away from that 3 lots of d, which was 5. So therefore y is going to be equal to 4 lots of 2 is 8. Take away 3 lots of 5 is 15. And therefore y is equal to 8 take 15, which is negative 7. On question 5, I'm told to rotate the shaded shape 90 degrees clockwise about the point O. And the point O is the origin in the middle of the diagram. So first of all, I'm going to take my piece of tracing paper and I'm going to trace the shape as accurately as I can. Now I'm told to rotate it 90 degrees clockwise, so I'm going to go this way, and I'm going to put an arrow on so I know which way is pointing straight up. So 90 degrees clockwise, place my pen or pencil on there and turn it 90 degrees until the arrow has moved around and is now facing 3 o'clock. Now it's just a simple case of transferring this shape onto the paper underneath. So by peeling it back, I can see that one corner is there, another corner there, and as I go around I can check that I've got the right corner, so this one is over here. Right, now if I join those lines up, I should get my shape. You should obviously use your ruler for all of those lines. Once I've done it, I'll check that I've got it right by going back to my original shape and just performing the rotation again. And it's in the right place. On question 5 part B, I'm asked to describe the single transformation. And there are 4 transformations. There are rotations, as we've done above. There are reflections. There's an enlargement. And there's a translation. Those are the 4 transformations. And I'm going from P to Q. And it's worth drawing an arrow on so I know I'm going from P to Q, and not the other way around. I'm going to mark a point on P, and I'm going to mark that same point on Q. And I'm going to work out how I've gone from P to Q. Well, it's not a rotation, as you can see, that's not spin round, and therefore it's not a rotation. It's not been reflected, so that's out, and it's not an enlargement. It stayed the same size, and it hasn't flipped over in the case of a rotation, sorry, an enlargement, -1. So it must be a translation. So it's a case of finding out how far I've moved from here to here. So I've gone across 1, 2, 3, and I've gone down 1. So I'm going to write that out. It's a translation. And I'm going to write that as a vector, so it is 3 to the right, so I'm going to write 3 on the top, and 1 down, or -1. Notice there's no line in between the 3 and the -1. On question 6, I'm shown a rectangle and told that all the measurements are in centimetres. And I'm asked to explain why 4x plus 1 here is equal to 2x plus 12 here. Well, the reason for that is that opposite sides in a rectangle are the same length. In part B, I'm told to solve 4x plus 1 equals 2x plus 12. So let's write that out so we can see that. 4x plus 1 equals 2x plus 12. And therefore I'm going to try and end up with x equals. So the first thing I'm going to do is I'm going to get rid of this 1 on this side. And I'm going to take away 1 from both sides. And if I do that, I'm going to be left with 4x equals 2x plus 11. And then I'm going to get rid of this 2x by taking it away from both sides, which would leave me with 2x equals 11. And I don't want to know what 2x is, I want to know what 1x is. So I'm going to divide both sides by 2. If I divide both sides by 2, I get 11 divided by 2 on the right hand side, which I can write as a fraction, 11 over 2. And if you want to, you can turn that into a decimal of 5.5. So x is 5.5. In part C, I'm asked to work out the perimeter of the rectangle. So the perimeter of the rectangle is all the way around the outside, so this distance here. So what I'm going to do is I'm going to add up what I've got. So I've got x, add x for these two sides here, and I'm adding on to that 4x for the side at the top, and I'm adding 2x plus 12 on as well. So I've got 2x plus 4x is 6x, plus another 2x is 8x, and I've got add 1, add 12, which is add 13. And what I've got to do now is take the value for x that I had here and substitute into here. So I've got 8 lots of 5.5 plus 13. Now 8 lots of 5.5, well 8 lots of 5 is 40, and 8 lots of a half is 4, so that's going to be 44. And then I've got 13 on, and 44 of 13 is 57. So the perimeter of my rectangle is 57, and they've already given me the units here of centimetres. It doesn't hurt to add them on anyway. On question 7, I'm given that 322 times by 48 is 15,456, and I'm asked to find the value of, in part A, 3.22 times 4.8. Well, 3.22 is 100 times smaller than 322, and 4.8 is 10 times smaller than 48. So I'm going to divide my answer by 100, and then I'm going to divide my answer by 10 from what I had originally, which is the same as dividing by 1,000 altogether. So if I divide this by 1,000, I'm going to get 15.456. All of the numbers have jumped over the decimal place 3 times. Similarly, in part B, I've got 0.322, which is the original number divided by 1,000, and I've got 0.48, which is 48 divided by 100, which is overall same as dividing by a 1 and 5 zeros, or 100,000. So this number divided by 100,000 will be 0.15456. Numbers have moved over the decimal point 5 places because of the 5 zeros here. In part C, slightly more complicated, they've rearranged the sum and they've told me that 15,456 divided by 4.8 is an answer. Now obviously looking at the original sum, if I rearrange that, 15,456 divided by 48 will be 322. So my answer must be something to do with the numbers 3, 2, 2. Now 4.8 is 10 times smaller than 48, and what that means is it will go into 15,000 10 times more. So I'm effectively going to multiply my answer by 10 times. So I'm going to have to add a 0 on the end here to say that 4.8 goes into 15,456 more than 48 would go into it. On question 8, I'm told that 2x squared equals 72. And 2x squared is the same as 2 times x squared equaling 72. And I'm asked to find a value for x, not all the values for a, just for x, just a value. Well, 2 times x squared is 72, and therefore we can find out what x squared is by dividing both sides by 2, in which case x squared is 36. And if I want to know what x is, I'm going to have to square root both sides. So the square root both sides, I'm going to get that x is equal to the square root of 36. Now the square root of 36 has two answers, one positive and one negative, so I can write down either of those answers. So I'm going to be given that x is either positive 6 or negative 6, and I can use either of those answers. In part B, I'm told to express 72 as a product, which means times prime. The first few prime numbers are 2, 3, 5, 7, 11, and factors, and a factor is a number that goes into the original number. So 72 is the same as 2 times by 36. This number here is prime, so I can stop. This number here isn't. 36 is the same as 4 times by 9. Now neither of those numbers is prime, so I'm going to keep going. So 4 is 2 times by 2. And both of those are prime, so I can stop. And 9 is 3 times by 3. And again, both of those are prime, so I can stop. So 72 is the same as 2 times by 2 times by 2 times by 3 times by this 3 here. Now if I was asked to write it in index form, I would write that as 2 cubed times by 3 squared. But I've not been asked to, so I'm okay just to leave it in this form here. And it's a product, they've all been times, they're prime, and they're all factors of 72. On question 9, given the plan and front elevation of a solid shape. In part A, I'm asked to draw the side elevation of the solid shape. So the plan is the same as the top, and from the top, this distance here represents the side. So I can see that it is 2 squares across. And also from the front, I can see I'm looking this way, therefore the side elevation of the solid shape will be this distance here. This is the height of the shape, so it will be 2 squares up. Just finishing that off, that is what the side of this shape will look like. In part B, I'm asked to draw a sketch of the solid shape. So I'm going to use the front elevation and I'm going to sketch that here. And if that's the front, the back will look roughly the same. So I'm going to draw the back over here. Again, the same size. And now it's just a case of joining up the corners that correspond. So that one goes to there, that one goes to there, that one goes to there, and so on. And that is a sketch of that solid shape. Now some people might want to use these as dashed lines, because obviously you wouldn't be able to see them if it was a solid shape. In question 10, I'm told there are 40 litres of water in a barrel and that it flows out at a rate of 125 millilitres per second. I'm also told that 1 litre is 1000 millilitres and asked how long will it take for the barrel to empty completely. So 40 litres is going to be the same as 40 times by 1000 millilitres, which is going to be 40,000 millilitres. Now, if I'm losing 125 millilitres per second, if I do 40,000 divided by 125, I'm going to get how long it takes in seconds to empty. So I've got to do this without a calculator, so I'm going to try and simplify this division a little bit. So I'm going to do this one divided by 5, and this one divided by 5. And that will get me on the bottom that I've got 25 over on the top, 8,000. And already the numbers are a little bit more manageable. So again, I'm going to repeat that. I'm going to divide by 5, and divide the top by 5, and I'm going to get on the bottom 5, and on the top I'm going to get 1,600. Again, if you're not too sure about that, go through the bus stop method. 5's into 8 is 1, remainder 3, 5's into 30 is 6, and filling in the zeros. And finally, I can divide by 5 again. And on the bottom I'm going to get 1, and on the top I'm going to get 1,600 divided by 5. So 5 doesn't go into 1, so 0, remainder 1. 5 into 16 is 3, remainder 1. 5 into 10 is 2, and then 0 there, so I'm going to get 320 over 1, which is just the same as 320. So my answer is 320 seconds. They haven't asked me to change it into minutes and seconds, so I can leave it as is. On question 11, I'm told that the length of a line is 63 centimetres correct to the nearest centimetre. So that means that the line is 63 centimetres to the nearest centimetre. And the nearest centimetres above that is 64, and below is 62. And therefore, in the middle, I've got 62.5, and in the middle here, I've got 63.5. So anything above 63.5 would actually round to 64, and anything below 62.5 would round to 62. So it's this area I'm interested in here. So the least possible length is going to be 62.5 centimetres, and the greatest possible length is going to be 63.5. Now technically this would round to 64, so the correct answer is 63.49 recurring. However, the exam board let you away with 63.5. On question 12, we're given a triangle ABC, and we're told to shade the region inside the triangle which is both less than 4 centimetres from the point A and closer to AC than it is to the line AB. So we'll deal with less than 4 centimetres from the point B first. So less than 4 centimetres from the point B, I need to take my compass and open it out to 4 centimetres. So from point 4 back to 0, that compass is now 4 centimetres wide. So if I place that on point B, I can now draw an arc. Everywhere inside that arc, I'll shade this lightly, everywhere inside this arc here is less than 4 centimetres from B, because this distance here is 4 centimetres and this distance here is 4 centimetres, as it's the radius of a circle. And part B of this question is closer to the line AC than the line AB. So the line AC is this line here and the line AB is this line here. Now, as it doesn't say use my construction lines, I could do this with a protractor. Normally it does, so I'm going to use a compass. So what I want to do is I want to bisect this angle here. And to bisect that angle, again I'm going to use my compass. I'm going to leave it at 4 centimetres, but it could be any radius, and I'm going to draw an arc that crosses both the line AC and AB. And that creates a point of intersection here and here. Now if I place my compass on those 2 points, and again I'm going to leave it open the same distance, create another arc here, and from the other side create another arc that crosses that one, and again gives me a point of intersection here. Now if I join the point A to there, that is going to bisect the angle BAC, and I get that this bit here is, for example, X, and this bit here would be exactly the same, it would be X. Now everywhere close to the line AC is going to be this side of this line, closer to this line here. But it also needs to be less than 4 centimetres from the point B. So it's going to be this region here. So that is less than 4 centimetres from B, it's inside that arc, and it is closer to the line AC. Notice I've not shaded in this bit outside, because that's more than 4 centimetres from B, despite being close to the line AC. On question 13, I'm told that Fred is taking a survey of magazines read by students, and I'm asked to design a suitable question that he could use to find out what types, and the key word here is what types, so the different types of magazines. So first off I'm going to need a question, and that's going to be pretty much taken from this section here. So what types of magazine do you read? And all of these words are coming from here. What types of magazine do you read? And I'm going to need some response boxes, so I'm going to put a minimum of 4 boxes in. And it's important that this last box is other. The other boxes I can call whatever I want. For instance, this could be TV, this could be sports, this could be gardening. Doesn't matter what I call them, as long as I've got this other box here, the people need to tick it. In part B, I'm told that Fred had the question, how many magazines have you read, on his questionnaire? And the answer boxes were a few and a lot. And I need to design a better question. Well, usually these questions are about something that's missing, and that is the time frame. So we need to say how many magazines do you read per, and again the time frame is not important. I'm going to go with month. It could be week, it could be year, as long as it's realistic. And again, I'm told I need to include some response boxes. So again, 1, 2, 3, 4. Now these need to make sure they don't overlap. So I'm going to have one for 0. I'm going to have one for 1 to 3, because this is discrete information. It can only take a whole number. I'm going to have 4 to 6, and then I'm going to have 7 plus. It's important that none of these overlap. So I wouldn't want 1 to 3 and then here 3 to 6, because I could put 3 in both boxes. And again, it's important that I've got this box here for more than. In question 14, I'm asked to work out an estimate for the value of 6.8 times 191 divided by 0.051. So when it says estimate, it wants me to round all of those numbers to one significant figure. So 6.8 to one significant figure would be, well, I'll circle the first number, which is significant, which is the 6, and have a look at the 8. The 8 means I need to increase this by 1, so that's going to become 7. And I do the same thing for the other numbers. So 191 to one significant figure is going to be 200, and 0.051 to one significant figure is going to be, well, the first significant figure here is the 5. These two zeros don't count as significant, and then I look at this 1 and it means the 5 stays the same. So to one significant figure, that will be 0.05. Now I'm going to use these numbers 7, 200 and 0.05 to do this calculation. So I'm going to have 7 times 200 divided by 0.05. So 7 times 200 is the easy bit, that's 1,400, and I want to divide that by 0.05. Now this is quite a tricky division to do at this moment in time, so I'm going to times the bottom one by 100 to get rid of this decimal and give me the number 5. So I'm going to times the top one by 100 as well, and then I'll have a fraction that's equivalent. So that's going to be on the top, and on the bottom I'm going to have 5. So I've got 140,000 divided by 5. Now, non-calculator, so I'm going to have to use the bus stop to do that division. 5 doesn't go into 1. Carry the 1. 5's into 14 is 2. Remainder 4. 5's into 40 is 8. And then I've got 3 more zeros to add on as I do the division. So my answer is 28,000. On question 15, I'm asked to write 64,000 in standard form. So I need a number between 1 and 10, so that's going to be 6.4. And that needs to be multiplied by 10 to the power of something to give me 64,000. So if I multiply it by 10, that will give me 64, and then I've got 3 more zeros, so I need to do times 10 to the power of 4. Part B, I'm told to write 156 times 10 to the minus 7 in standard form. So 156, again, I need a number between 1 and 10, so that's going to be 1.56. And 1.56 times by 10 squared would be 156. So I've taken care of that, and I've still got times 10 to the power of minus 7. Now what I've got to do is I've got to combine these two to get 1 power of 10. So 1.56 times by 10 to the power of, and work out this number. Now when I'm multiplying powers, I need to take the 2 and the negative 7, and I need to add them. So I'm going to do 2 add negative 7, and that's going to give me, these two go together to become take away, and I'm going to get negative 5. So it's going to be 1.56 times 10 to the power of negative 5. On question 16, I'm asked to factorise fully 4x squared minus 6xy. So first off, I'm going to find the factors of 4 and 6. 4 is 1 times 4 and 2 times 2. And 6 is 1 times 6 and 2 times 3. And I'm looking for the highest common factor there, and the highest common factor is 2, because it appears in both lists, and it's the highest number. So that means 4x squared I can write as 4, you can write as 2 times by 2 times by x times by x. Take away 2 times by 3 times by x times by y. And then looking at that, I can see what's common to both lists. So I've got a 2 here, 2 here, so I can definitely take a 2 out of both of these expressions. And I've got an x here and an x here, so I can definitely take an x out of both expressions. And there's nothing else the same. I've got 2 and an x here and 3 and a y here. So my answer is going to start with 2x. And I need to know what I'm going to multiply by 2x to give me 4x squared. Well, what I'm left with here is 2x. So if I put 2x in there, 2x times 2x would give me 4x squared. I've still got take away, and I've got 3y here. And 3y times by 2x would give me 6xy, so I'll factorise that fully. In part B, I've got a quadratic, x squared plus 5x minus 6. So what I need to do is find two numbers that multiply to give me negative 6 and go together to give me positive 5. Now, the answer here is going to be x plus 6 and x minus 1. And I can do that by inspection. Once you've done it, it's worthwhile multiplying it out, x plus 6 and x minus 1, just to check that that works. So that's minus 1x plus 6x minus 6. These two here will go together to give me the positive 5x that I'm after as my middle term. So my answer is x plus 6 and x minus 1. On question 17, I'm told that Lucy did a survey about the amounts of money spent by 120 men during their summer holidays. And I'm given the information in this table, but it's important that I note that this is already the cumulative frequency. So I'm not given the frequencies, I'm given the cumulative frequencies. So all I'm going to do is I'm going to plot a graph from that. So I need to know that when I draw a cumulative frequency curve, I use the upper limit here of the amount spent, and I use this value. So that's going to create a point for me where I go along 100 and up 13 on my cumulative frequency axis. And similarly, this one here is going to be 150, and I'm going to go up to 25. Now sometimes I have to create this cumulative frequency by adding up the frequencies as I go along, but they've already done that for me here. And then so on for the rest of the numbers. So I've got 242, I've got 250 and 64, I've got 393, I've got 350 and 110, and I've got 400, the last one, 400 here, and 120 here. So all I've got to do now is take that information and put it on the cumulative frequency diagram. So the cumulative frequency diagram is on the other page, and this is what the scale looks like. I've got an amount spent going horizontally, and I've got the cumulative frequency going vertically. So the first point was 113. So I'll come along to 100, which is here, and then go up to 13. Now I need to make sure I read this scale carefully. So at the moment, it goes from 0 to 10, and I'm going to just check whether it goes up in ones. So 1, 2, 3, 4, 5. It doesn't go up in ones. I'm going to try 2s, 2, 4, 6, 8, 10. So this scale is going up in 2s. So I want 100 and 13. So 100 and 13 therefore will be in that region there. And I'm going to mark it with a cross. And I'm going to do the same for all these other points. So 150 and 25, 242, 250 and 64, 393, 350 and 110, and 400 and 120. Okay, as it's a cumulative frequency diagram, I'm going to join those all up. Now it's important that I join this first point back to the lowest possible value. Now from my table, that was 0, so I'm going to go back to 0 here, and that's given by this number here. That won't always be 0, so do remember to check it. Now I don't have to join them with a curved line because it doesn't ask for a curve, it just says a cumulative frequency graph, and I'm going to join them all up with my ruler. Now obviously with a pencil it will be a little bit more accurate, but you get the general idea. Okay, so that's my cumulative frequency graph. In part B, I'm asked to work out the median. Now the median is halfway between the amount of people I've got, the number in the middle, and I've got 120. So 120 divided by 2 is 60. So I'm looking for the 60th person. So again, on the cumulative frequency graph, I'm going to find the 60th person, which is here, and I'm going to draw a line across, again with a ruler, until I hit my cumulative frequency curve. And if I bring that down, using this scale here, it's round about 250, and again I've got to check what I go up in. Now I know that 200 to 250 in 5 squares, so I'm going up in 10, so So that is going to be 240. So the median amount spent is going to be £240. In part C, I'm told that a survey of the amounts of money spent by 200 women, so a different amount of women during the summer holidays, gave a median of £205, and I'm asked to compare them. So the men spent on average, that's what the median is, £240, and the women spent on average £205, and therefore on average the men spent more, and that's what I'm going to write here. And now I'm going to give my justification. On average the men spent more since their median of £240 was higher than the women's of £205. On question 18, I'm shown a diagram. I'm told that the circle has a centre of O, which could be important, and that ABC are on the circumference, which I can see from the diagram, and that DCO is a straight line, so DC to O is a straight line, and that is important. I'm told that DA is a tangent to the circle, and that's this line here, and that ADO is 36, that's shown on the diagram. And I'm asked to work out the size of angle AOD. So AOD is this angle here. Now, from looking at my diagram, I can tell that this here is 90 degrees, because this here is a tangent, and this line AO is a radius. And I know that the angle between a tangent and a radius is 90 degrees. And therefore, if I look at this shape here, I can see that I've got a right angle triangle, and therefore that should add up to 180 degrees. So if I take the 90 degrees and add on the 36, I get 126, and then if I take that away from the total angles in a triangle of 180 degrees, I'm going to get my answer for AOD, which is going to be 54. So AOD is 54 degrees. I'm also in part B asked to work out the size of the angle ABC. And ABC is this angle at the top here. Now again, I need to use one of my circle theorems here to work this one out, and I can tell that the angle ABC here is linked to this angle AOC here. So I've got AOC there, and I've got ABC up here. Now this is a form of a circle theorem where we have an angle at the circumference and an angle at the centre. We've simply moved that point round until it's come to here, and I know that the angle at the centre is always twice the angle at the circumference there. So my angle at the centre I've already worked out as 54, and therefore my angle at the circumference is going to be half of that, so 54 divided by 2, which is 27. And in part B, part 2, I'm asked to give a reason for my answer, and that is that the angle at the circumference is half the angle at the centre. Now you can of course use the other variation of this, which is the angle at the centre is twice the angle at the circumference. It works perfectly fine as well. On number 19, I'm shown two graphs, y equals a half of x plus 2, which is this one here, and 2y plus 3x equals 12, which is the one here. And I'm asked to use a diagram to solve the simultaneous equations. Well, the two graphs cross here at point 2,3. So that's the point 2,3. And that is the solution to part A, which is x equals 2, y equals 3. If I put x equals 2 in here, I will get that y is 3, and if I put x equals 2 in here and y equals 3, it will also work. In part B, I'm asked to find an equation of the straight line which is parallel to the line y equals a half of x plus 2. So if it's parallel, that means its gradient is the same. The gradient of this line is half. That's the gradient there, how steep the line is, which means that for every one square I go across in terms of units, or 1 unit across, I go up 1/2 of a unit. So that's a half, and I went across 1. And I'm told that this new line passes through the point 0,4. That's the point 0,4 there. So my line is going to follow the same gradient of this, so it's going to go across like that. So that's my new line, and I just need the equation of that line. Well, as the gradient's the same, it's going to start with y equals a half x. And all I need to do is work out what I add or subtract on the end. And that's the intercept. So I need to know the intercept. And the intercept is where it crosses the y-axis. We call that the y-intercept. And therefore it crosses the y-intercept at 4. So the equation of my line is y equals a half x plus 4. On question 20, I'm asked to solve the inequality 3t plus 1 is less than t plus 12. So I'm going to solve this exactly like an equation, and I'm going to do the same to both sides throughout. So to start with, I'm going to take away 1 from both sides, and that's going to leave me 3t on the left hand side is less than t plus 11. Now I'm going to take away t from both sides, which is going to give me that 2t is less than 11. And I don't need to know what 2t is, I need to know what 1t is, so I'm going to divide by 2 on both sides. And that will get me that t is less than 11 divided by 2. And I'm going to write that as t is less than 11 over 2, which obviously is the same as 5.5. In part B, I'm told that t is a whole number, and I need to write down the largest value of t that satisfies this. So I know that t is less than 5.5, and the first whole number that's less than 5.5 is 5. On question 21, I'm told that m is directly proportional, which is equals k times L cubed. Notice it was the first letter I found, the last letter I found, including its power or other operation, and when it said directly proportional, I put equals k times. If it had been indirectly proportional, then I put equals k divided by. I'm then told that L is 2 when m is 160, so I'm going to substitute those numbers in. M is 160, k times by 2 cubed. 2 cubed is 8, so k times by 8 must be equal to 160. In which case k must be 160 divided by 8, which means that k is 20. And I can now take that number and put it back into that equation there. And therefore m equals 20 times by L cubed. I'm then told to find the value of m when L is 3. So when L is 3, m is going to be equal to 20 times by 3, which is what I'm told L is, cubed. So m is going to be equal to 20 times by 3 cubed, which is 27. And 20 times by 27 is going to be 540. So m is 540. On question 22, I'm told that a call centre received 64 telephone calls, and I'm given that information in the table, and it's split into various groups, and those are shown on the left hand side here, and the frequencies for each group shown in the second column. So the first thing I'm going to do is I'm going to have a look at the diagram down the bottom here, and they've marked horizontally the lengths of the calls from 0 to 50, and then up the side they've left it blank. Now for a histogram I know that I need to have a frequency density. So I'm going to work out the frequency density, and to do that, the first thing I need to do is work out the class width. And that I find by going from this number 0 to the second number 5. Well, that would be 5. And I repeat that process for the second group 5 to 15, which is 10, and so on for all the other groups. Once I've worked that out, I need to find out how tightly packed this frequency is within this width. And to do that, I'm going to find the frequency density. Now the frequency density is found by doing the frequency divided by the width. So 4 divided by 5, which is 4 over 5, which is 8 over 10, which is 0.8. So the frequency density for that first group is 0.8. For the second group, much easier, 10 divided by 10 is 1. For the third group, 24 divided by 15, and again, slightly trickier to do, 24 divided by 15 is 24 over 15. can divide both the top and bottom by 3 because I'm not allowed a calculator to get 8 over 5, and that'll turn into 16 over 10, which is 1.6. Fourth group, 20 divided by 10 is 2, and the last group, 6 divided by 5, or 6 divided by 5, is 12 over 10, which is 1.2. Now all I need to do is transfer this information, the length of calls and the frequency density, which are marked on the axes, onto the graph paper. Now I've got to choose my scale because I'm not told. There are a couple of scales I could choose. I'm going to start with the easiest possible scale, which is I'm going to assume that this from here to here is 1, therefore that's 2, 3, and so on. So first group from 0 to 5 goes to 0.8. So from 0 to 5 goes to 0.8. And my scale's nice and easy. That's 0.8 there. Similarly, from 5 to 15 is 1. So from 5 to 15 is 1. And then from 15 to 30 is 1.6. 1.6 will be there. And then from 30 to 40 is 2. And from 40 to 45 is 1.2. Now that's not the only scale I could use. I could use a slightly different scale which would have made my histogram bigger, and I could have started here at 0. This would be 1 and this would be 2. And that would have the effect of doubling the height of all of my bars. However, that would have made the histogram a little bit more complicated to plot, and it's a good idea to make your life as simple as possible. In question 23, I'm given a tree diagram. I'm told that the probability that Vichy wins any game of chess is 0.5, which is shown here. Probability that he draws is 0.3, and then I'm asked to work out the probability that he wins both games after I've completed the tree diagram. So first of all, I need to work out the probability that he loses. So on the tree diagram, the branches must always add up to 1, so this is going to be 0.2. And I'm going to copy all of that information to the second game, so 0.5, 0.3, 0.2, as the probability that he wins any game isn't going to choose from one to the next. In part B, I'm asked to work out the probability that Vichy will win both games. So winning both games is this part of the tree diagram. So he wins the first game, and then he wins the second game. So that will give him a win, and then another win. And therefore, the two probabilities I'm after are 0.5 and 0.5 again. Now I'm going to do 0.5 times by 0.5. Now you can use it as that, or you can call it half. Sometimes easy for some people. So a half times a half is 1 quarter. Therefore 0.5 times 0.5 must be 0.25. Either of these answers here will suffice. On question 24, I'm given an equilateral triangle ABC, and I'm told that D is on the line BC, and that AD is perpendicular to BC. Now I'm just asked to prove that the triangle ADC, which is this triangle here, is congruent to the triangle ADB, which is this triangle here. So I'm going to draw both of those triangles out. So I've got A, B, D, and then I've got the other triangle going in the other direction, which is A, D, C. And I'm showing that that's a right angle. Now I can start to add some information to my triangles. So I'm told that they're equilateral, so I know that this angle here is going to be 60 degrees. And therefore this angle here, as it's also part of the original triangle, is also going to be 60 degrees. And I can summarise that by referring to this angle as ABD. So ABD equals ACD, and I'm going to give a reason for that, and that is that it's an equilateral triangle. Okay, next piece of information. I know that the angle ADC is 90, but I can also tell that this angle here is going to be 90, and that's because this line B to C is a straight line. So I can say that this angle is 90 because B to C is a straight line. So ADC is equal to ADB, and they are both equal to 90. And that's because there are 180 degrees on a straight line. Now I also know that this side here, AB, is going to be equal to AC, and again that's because of ABC being an equilateral triangle. So what I've got here is two angles. This angle here, I've got another angle here, and then I've got a side that's corresponding in both triangles, i.e. it's in the same place. AB is in the same place as AC. And therefore the triangles are congruent because of angle, angle, side. And I can write a comment to that effect. So angle, angle, side proves congruency. In part B, I'm told to hence prove that BD equals a half AB. So B to D equals a half of A to B. So to do that, what I'm going to say is that I know that BD equals DC because of congruence. Or in other words, this triangle is exactly the same as this triangle, so this length must be exactly this length. Now I know that AB is equal to BC because it's an equilateral triangle. So where I've got AB here, I'm going to substitute in BC. So I've now got that BD is a half of BC. So B to D is a half of B to C. And I know that B to D is equal to D to C, and therefore both of those two added together is the length BC, so that makes sense. On question 25, I'm given the formula 1 over u plus 1 over v equals 1 over f here, and I'm asked to work out the value of f when u is 2.5 and v is 3 1/3. So first of all, I'm going to turn the mixed number 2.5 into an improper fraction, and that's going to be 5 over 2. And similarly, the mixed number 3 1/3, I'm going to turn into 10/3. V equals 10/3. I can now take those two numbers and substitute them into this formula. So 1 over 5 over 2 plus 1 over 10/3 equals 1 over f. Now, finding the reciprocal here, which is 1 over this, is going to be 2/5. And similarly here, this is going to be 3/10. Or you can think of it another way, 1 divided by 5 over 2 is going to become 2/5 if I follow through with that division. And that's 1 over f. So all I've got to do now to work out 1 over f is do this addition here. So 2/5 would be 4/10. Added on to 3/10 is going to be 7/10. I just found an equivalent fraction here to 2/5. Okay, so 7/10 is equal to 1 over f, in which case again, finding the reciprocal, f must be 10 over 7. In part B, I'm asked to rearrange the same formula to make u the subject. So I'm going to start by writing that out here so you can see it a bit clearer. And I'm going to subtract 1 over v from both sides. And that's going to get me that 1 over u is equal to 1 over f minus 1 over v. I'm now going to take this right hand side of the equation and try and write it with a common denominator. And the common denominator for f and v is going to be fv. So that's going to be fv. Now I need to work out the numerator. So 1 over f turned into fv. And times in the bottom by v, so I've got times the top by v as well. So I'm going to get v over fv. I need to take away from that 1 over v, the same logic, 1 over v turned into f over v. Well, I'm times in the bottom now by f. So I'm going to times the top by f as well. And that's going to get me f over fv. So 1 over u is equal to this expression here, v minus f over fv. And therefore to find what u is, I'm going to take the reciprocal of both sides. So u is going to be equal to fv on the top divided by v minus f. On question 26, I'm given the curve equation y equals f of x, which is this curve here. I'm told that it's translated which means move to the point 0, 0 is mapped onto 4, 0. So it's moved from here to there. So that's a translation of 4 to the right, 0 up and down. And I'm asked to find an equation of the translated curve. Now I know that when the curve moves 4 to the right, I'm dealing with a translation that is f of x minus a. And in this case, the distance I've moved is 4, so a is going to be 4. So the curve I've got is y equals f of x minus 4. In part B, I'm given the graph of y equals cos x from 0 to 540, and I'm asked to sketch the graph of y equals 3 cos 2x. So cos 2x is the first part that I'm going to deal with. And cos 2x is a stretch parallel to the x-axis of scale factor 1/2. So I'm going to take all of these points here, peaks and the troughs of the curve, and I'm going to stretch them parallel to the x-axis scale factor of 1/2. So this one doesn't move. This one here is going to get compressed from 3 squares to 1.5 squares. So it's going to move to there. This one that was 6 squares is going to come to 3 squares. This one here, which was 3, 6, 9 squares away, is now going to be 4.5 squares away. And I'm going to get the curve being squashed so that it looks same shape, just a little bit steeper. Now obviously I can spot the pattern of this curve now, so I'm just going to continue that on. So I'm going to move up from here to there, I'm going to come back down again, there, and back up again to there. So that's the curve y equals cos 2x. Now I need to deal with the 3 at the start, and that's a stretch parallel to the y-axis in this direction of scale 3. So I'm going to take all of these points here again of cos 2x, and I'm going to apply a stretch of scale factor 3 parallel to the y-axis. So this was 1 away, so now it's going to be 3 away. This was 1 away, so now it's going to be 3 away. This was 1 away, 3 away. And I'm working my way along, stretching that curve parallel to the y. And now it's a case of joining those up to get my curve for y equals 3 cos 2x. That concludes the exam paper.